Good morning, ladies and gentlemen. Thank you very much and welcome to Buildtastic, the first of our construction virtual events. I'd like to give a big warm welcome and thank you to our friends and colleagues at ISG. We've got Karen Weiger, Ben Callan and Donatella Firorella. So over to Karen now to introduce the team to tell you all the exciting things that ISG are doing. Thanks very much and enjoy.
Good morning. Thank you, Debbie and team, for allowing us to come along to your special event here today. I'm Karen Weiger and I'm from ISG, and we are proud to be supporting West Suffolk College for UK Construction Week, and namely Buildtastic at your college, which is the UK's largest built environment event, celebrating all the great things about construction. So this year, obviously, we're having to host it virtually for obvious reasons, but I'm sure myself, Ben and Donatella, who will be talking to you today, will come and see you just as soon as we can. Thanks, Ben.
Yep.
So I'd like to introduce our team. So myself on the left, Karen Weiger, as I've mentioned. Now I'm Education Engagement Manager and have been dealing with Debbie and the team at the college for a number of months now. My colleague Ben, who's there in the middle, he's our BIM Manager, and I'll allow Ben and Donatella to introduce themselves as they speak. And thirdly, Donatella, who's also a BIM Manager at ISG, and we're going to be talking to you today about BIM, which might be a strange acronym, and technology. Thanks, Ben. So in terms of who we are, next slide, thanks, Ben. So as a company, some of you may or may not know ISG. So we are a globally privately owned construction business. And what we say is we deliver those places in your communities where you live and where you work, where people and businesses thrive. Next slide. So what in fact do we do? So when you kind of look out or you kind of see across the horizons, often you see lots of cranes, and that's an indication of the amount of construction activity in your community. And as a business, we do three main threads to our business. So on the left-hand side, we do fit out. We are involved in engineering services as a division, and we have a large construction division. And I am based in our Aldgate office in London. Thanks, Ben. And the sectors that we operate in, I've just put some pictures there just to give you an idea. So we construct large and small offices, as well as fitting those out, new retail institutions. We're involved actively in technology, science and health, which obviously is very prevalent at the moment, supporting on the health of our nation during the COVID period, hospitality and leisure, and education and the public sectors, of which we've got a number of frameworks and work with a number of schools and colleges just like your own. Thanks. Okay, so some of the things that make us different in terms of our kind of size, we're a 1.9 billion revenue business in 2020. And you can see some of the accolades that we've got there, you know, kind of number one, voted number one as a fit out company, with many projects of a kind of very prestigious nature in London and throughout the world, actually. We provide the data center market as a key provider with many of your known brands in your house all the way across Europe. And health and safety is absolutely paramount to us. Thanks, Ben. So where we work, as I mentioned, so globally, we operate across 24 countries around the world, and ISG employ over 2,800 people, so pretty big. And obviously with those three global hubs within Europe, Middle East and in Asia. And thank you, next slide. And you can see on the map there, your local office to you at the college would be Cambridge, and Ben, myself and Donatella are all based from our Aldgate office in London, in the city, which is in fact our head office too. Next slide, thank you. So in terms of our kind of brand and our vision, we have really kind of our key values are really probably much the same as what you'd like to do at the college. Dream smartly, frankly, always caring and never stop learning. And that kind of theme runs all the way through our business. And in terms of how we operate, our brand and our vision, we like to run through in the communities and with our people every single touch point with our communities, that kind of ethos. Thank you. So I'd like to hand over to my colleague, and I'll hand over initially to Ben, but we'll be taking questions at the end of the presentation. So do please use the chat facility, and at the end of the topic, which is all about BIM and technology, we're happy to answer any question from the chat, or also do ask any questions live to our speaking panel. Don't be afraid to do so, and we can try and answer some of those questions for you. It's fantastic that we've actually got an opportunity to come and meet some of you today. So thanks very much. I'll hand over to Ben.
Cool, thanks Karen. Hello everyone. Yeah, like Karen mentioned, my name's Ben Callan. What I'll do before we kind of jump into the what is BIM, what does it stand for, what is it within the industry, I'll just introduce myself, and then I'll let Donatella just introduce herself as well. So I've been working at ISG for the last 6 years. 3 of those years have been within the BIM department. I actually came through into construction from university, however, not studying a traditional construction qualification. I actually came through from criminology, so not exactly construction focused, shall we say. But what I've done is over the 6 years, I've kind of come in and I've worked across multiple areas of the construction industry through ISG, and undertaken lots of different roles. And essentially, I've kind of found myself and ended up working in within ISG's BIM department. Donatella, do you want to just quickly introduce yourself?
Of course, thank you. Good morning, everyone. So my name is typically Italian, and my accent too. So obviously I am coming from Italy, and I had my study in Italy. So I studied engineering, and I was very passionate about art, and I found that there was a great link there to learn about architecture and how this is applied in construction. And that's why I decided to study construction engineering. And then I was working with the most traditional roles like designer, but also estimator, so very traditional stuff. And then I just thought there was no innovative enough for me, and I was looking for something that was a bit more moving, exciting, a bit more digital, let's say, something more advanced. And that's why I had another master where I learned a lot about BIM, and I decided that I was very happy with this career, and then I jumped on it. And I am working for ISG for 1.5 years, but I am working in UK in construction from almost 8 years, but in UK from 6 years as a BIM specialist, manager, coordinator, different roles. But yeah, but about this digital world, I think is probably one of the most advanced in construction. Thank you, Ben.
No, thank you. And I think it's very kind of important, and I suppose the kind of main takeaway is that there's so many different routes and avenues into construction. Obviously, there's the kind of old traditional STEM qualifications going through science, technology, mathematics, and all of these potential routes. But what we're seeing nowadays, and certainly through kind of the delivery of BIM and what this term BIM is it's opening up a lot broader depth and a lot of a more broader route into construction. What we'll do over the next few slides, we talked about at the end, is it's essentially some of the technology that we utilize around BIM and what it is. And you'll start to see that there's actually a lot of specialist subjects, a lot of specialist routes into construction that you wouldn't traditionally believe so. So kind of jumping into it, what is BIM? Well, BIM stands for, the actual acronym itself, BIM, stands for Building Information Modeling. And what I've got on screen there, so at its heart is BIM is the technology we use to kind of improve how we share information and deliver projects. Yeah, so BIM traditionally is the delivery of 3D design information, 3D models, 3D modeling, everything kind of 3D, as opposed to some of the old kind of traditional routes. And what it's there to do is cut out some of the old traditional inefficiencies around construction. So construction in itself has always been quite an old school, very traditional industry. But what we're seeing over the previous couple of decades, is actually it's starting to catch up, and it's starting to play a more vital role in terms of technological advancements and how we implement digital technologies. And this implementation of BIM, and what it's trying to do is cut out it's to cut off the fat, trim the fat off of how we would traditionally deliver a project. So where there can be a lot of inconsistencies or uncertainty around how you build a building. So one typical example could be the cost for how we build a building, or the time it takes, or the amount of materials, all these different bits and pieces. With the implementation of BIM and the technology that we use, we can start to refine that information a lot earlier in the project, and a lot more detailed, to actually bring some proper benefit. And it's not just there to benefit the likes of ISG. Obviously, ISG are a main contractor. We're predominantly responsible for delivering projects to clients with the help of certain subcontractors. But it's not just there as a benefit for us to be able to save cost and time and program. It is there to benefit all members of a project, of the industry, you know, from the client side to local communities, you know, being able to engage with schools and teach through the technology we use, as well as obviously our supply chain members as well. And it's drawing back to that idea of trimming the fat, cutting these inefficiencies out of project delivery. So what I'm going to do over the next couple of slides, or what me and Donatella are going to do, sorry, is talk about some of the technology we use, how it talks with different software that we use, the different technology that we implement, and look at some of the kind of the fun side of construction, shall we say. You know, construction's not just this this idea of muddy boots, concrete, bricks, and you know, it's not that. It's developing into something a lot more technological, a lot more digital. And what I'm hoping over these next few slides is we'll try and showcase that. So Donatella, if you wanted to just kick us off.
Yes, of course. So this one is, so as said before, we are trying to collaborate quite a lot with all our all the people that are in this construction process, and this is really the first step for us. So we are trying to design in a smarter way, definitely smarter than before, when we were using just papers or just 2D. And this is one of the main software that we are using. That is called Revit. This is authorizing for design. So wherever we put together the walls, the ceilings, the floors, and as you can see, you can set up different things. So this is the place where actually you decide the thickness of the wall, the levels, how many levels you have in a building, how they are coming together, and then you can always look at it in 2D and 3D. And I think this is the magic of this software, because all the time you are drawing something in 2D, then you can look at it in 3D and having a more comprehensive idea of what it is happening in your design. And this is a big revolution from the previous traditional design. Also, this is used as a collaboration tool, because more people can draw something in the same project. So we can have different files, and different files can work together in a smart way. They can synchronize with each other. and it is really working. We are trying to keep it up, the work in progress with these models. We share it with the whole team every week, so actually all of us are informed that there is not so much loss of time in the sharing, because before you have to post probably the 2D drawings or the big papers. On Friday you spend 2-3 hours just to put together everything on the paper and post it out. And now we are in this place where actually we can share all this information with a couple of clicks and 10 minutes of transfer. And what else? Do we have anything? The video is finished.
Yeah,
No,
the video just plays
more or less. I'm waiting for. Do we share? Do we show the 3D in this video?
Yeah, it does. It drops
At some
up.
point
It
we
drops
get.
up.
Yeah, we get there. Yes. Sorry, what were you saying?
I think it's also worth mentioning is obviously we're showcasing this specific piece of software here, Revit, and it's not to say that it's just main contractors that use this information. Traditionally, it's designers, so it can be architects who are doing the kind of the external look and how the internal feeling of the building is represented. It could be used by structural engineers to design the structural elements of the building, so how it stands up, how it is designed so it doesn't just fall over the moment there's a strong breeze, or you know, how we can get like mechanical and electrical consultants involved as well, so the more technical sides of how we develop a building. So looking at things like the heating and lighting and ventilation, and this is a type of software. I'm not saying this is the only software, there's loads of other software out there, but Revit is a typical example of how we can utilize 3D and 2D information to better visualize the project. And what the video was showing was essentially how we were drawing in the 2D space. However, at the same time, we're drawing in that third dimension as well, which opens us up to additional and a lot more capabilities around how we can use this information.
And well, this is something that will come out later in the presentation, but we will show a lot of software, and all of them are more or less sorry. Yes, that's it. And so basically we have to learn a different software and how they work with each other. So in this case we are showing this this software, but because this is the most used for building. But if you are designing probably an infrastructure, a long bridge or a long road, there will be some other projects that are more applicable, or they are the most used in the industry. So the beauty of this is that we have to learn a lot of software. We are always learning something new. It's very challenging, and also the fact that they work together in different ways is something that we need to learn and understand. And I found that this is one of the most fascinating things in this digital world. A big challenge for us, but very interesting.
Definitely. Cool. So that brings us on to, so Revit is predominantly the tool for how we can design in that 3D space, but then what we'd start to learn, what Donatella mentioned a second ago, is how we can utilize that 3D design, that 3D information, that third dimension moving forward. So going back to talking about the different disciplines on the project, so you know, you could have an architect producing a 3D model, a structural engineer producing a 3D model, a mechanical and electrical engineer producing a 3D model. You could have 10 or 15 different supply chain or subcontractors producing a 3D model. And what we're able to do is, like a big jigsaw puzzle, a 3D jigsaw puzzle, we're able to stitch that together to get a full view of the project. So this piece of software here, Navisworks, it's a little bit cartoony looking, but it does offer some benefits. What we're able to do is we're able to take all the individual models from all the different parties on the project and stitch them together like a big puzzle. So what you're actually looking there on the left-hand side, this image here, is actually a series of lots of different models. We've had all these different parties on a project produce all these different models, and we're able to bring it together into one single space, this one single project. Yeah. So we've got this one single project. This is this single space, this single source of everything relating to this project. And what we're able to do is we're able to actually, utilizing that third dimension, fly through the model. Unfortunately, we haven't got a video. We've got a series of images just to kind of portray this. But we're able to fly through this model and visualize the design in 3D. Now, if you can imagine, not everybody on a project is proficient in the reading of drawings, the understanding of how buildings are made, in what certain pieces of equipment are. Certainly with our clients, you know, trying to design with them, to develop the project with them, to get them to interpret and understand what they're physically going to get at the end can be quite tricky. So what we're able to do is, utilizing this software, Navisworks, is bring all the information together, and we're able to visualize the design in a 3D space. This 3D design, we can then go in and we can interrogate, we can query bits and pieces, we can raise issues and say, no, that shouldn't be there, it should be over there. Or, you know, this example over here, what we're looking at is essentially a clash detection report, which is the term given to when we run automated tests between two different models, and then return up every instance where there is a physical clash. So we can see here we've got some pipe work, what's in green here that I'm highlighting with my mouse, and what's in red is a structural beam, a steel beam. And instantly we can see that no, that pipe can't go there because that's not going to be feasible on site. We're not going to be able to install it like that. We can't have a pipe going through a beam. That's not going to work. So what we can do with that is we can highlight back to the designers who are designing the pipe work and say, Mr. Engineer, can you drop your pipe work to run underneath that beam, or can you move it in a different position? And what it enables us to do is interrogate in that 3D space and really get into the finer detail of looking at everything in one area, one space, one model, one project. And you know, people are a lot more receptive to understanding the third dimension than they are perhaps the 2D, which is the kind of old traditional 2D layouts, 2D plans, drawings that most people are familiar with on a project. So that's a key technology that we utilize. Again, it's not the only technology that we utilize for this purpose. There are others, but this is probably one of the most well known as Navisworks.
Ben, let me say something, because probably someone of the students don't know how it was working before and why this is so much revolutionary. Like, I think that we did have all the project in place. We had these drawings, but they were obviously, the designer were trying to coordinate, but it was happening. They were trying just to overlap the two drawings and looking at it as better they could. But obviously there were a lot of clashes that were not that much visible, and this technology is allowing us to put things all together and look at them in a way that actually everything is understandable, because here you can see the beams, you can see the pipes as well, and that is clear to anyone. But also, before, we didn't have a lot of information, then now we are in due to look for. So, for example, the external underground services, or some more external service that we were neither aware that we had. And you go to the site, you try to open the site, and then you find all these services that actually are on the way, and you have to change everything in your drawings. And this is something that we are working on. So actually we can prevent all these clashes before going to site, and making longer our program, and obviously having overcost. So that's why this is so much important for us in this point in time.
Yep. Okay, there you go.
So in terms of program, so the program is the time program, where actually we do have a planner per each project that is putting together a time program for the project. And before, there was really a very big graph with the bar graphs. And it is still kind of difficult to understand to me. I mean, you just see, well, it's not difficult, but it's still like a lot of bars, and you have to read it through. But obviously, if we are putting together, we call it 4D, where actually the fourth dimension is the time. So we use a 3D. We try to put together the time with the 3D, so assign to each part of the building a specific construction time. So if we know that on that week we are going to put the pile down, we will assign these in the 3D. In this software, this is called Synchro. This is allowing us just to put together the program with the 3D. And actually, when we assign the set of object to this time frame, then we can have a video that is showing us how the elements are coming together on site. This is a brilliant tool that we are using also for logistics. So you have been seeing that there are the cranes in here. There is a big operation for us on site that it's written on the program, but on the bars it's not really coming together. I mean, it's there, but it's not that understandable. And then we have a lot of spatial clashes that in the program are not really something calculable that much. Then we have definitely we have other plans going on. We can assess how we get into the site. If there is a lot of traffic, how we can make sure that actually all the tools are fitting, all the plants are fitting, they can turn around. We have enough space for store the materials around. We build up this video where actually we can see what is working, what is not working. Sometimes we have some special clash that we look at. It's in the program, but you don't see it because it's not evident. But obviously, with the video in place, all this perception is changing completely because you see it, you look at it, and you understand it in the first place. Either for the client, this is a very important tool because there is a typical case where the bar graph doesn't say anything to us, but then when we show to all our stakeholders this video, also to the neighbors, we use it a lot for neighbors to explain what is happening, why we are making all this noise on site, why you see all this material coming in and out. And we are very happy to show this and to share it because it is giving a great understanding of what we are doing, and actually we are working quite hard to make it right. And this is a typical thing that the clients really like to have, and it is allowing us to our job a bit better. I think the last bracket about the 4D is that is not that easy because I mean the video and the technical bit, it's easy for us, but putting together all the needed information is a long operation because we need to have a lot of input. We have a planner that is working on the time program, but this is like just a set of different information. So how many plants do we have on site? How many people do we have on site? How many subcontractors are working on site at the same time? And each subcontractor will have a different time program. So actually we are putting all this information together. When are we going to have the right drawings in place? When are we going to have the approval from the client? So there is so many information that we need to put together before getting to this nice video. Actually, is the hard work more than putting this in place, but this is the stronger in terms of understanding, and it gives a very clear idea about what we are doing at the end. Do I miss anything else? Do you want to add?
I think you've hit the nail on the head there.
Good.
It's essentially, what you're drawn on. It's that visualization of the program. It's the making a traditional 2D piece of information 3D to enable more communication, better communication with others that might not be as knowledgeable or in the know when it comes to planning a project, how we deliver a project. The next piece of software that we utilize, and some of you might recognize on the right hand side what that building is, but the other piece of software that we utilize is called Autodesk Recap. Now, this is a very intelligent, smart process, but essentially what you're looking at on the right hand side there is a combination between the 3D model that we showed earlier, i.e. what was out the federated model, and what is called a point cloud scan. Now, a point cloud scan is essentially a build-up of what you can see on the left-hand side there. Sorry, getting a bit pushing and pulling people to around the screen. What's on the left-hand side there is actually a build-up of millions and millions and millions of small points. Each point is a pixel, basically, and it's a build-up and a way in which we can capture on-site conditions. So to put it into perspective, a main contractor such as ISG might win a project from a client whereby we have to go out and fit out an internal space. Now, when we say fit out, we mean that the structure has already been installed, the facades, so the glazing and the windows has already been installed, and the main structural core in the middle, the structural frame in the middle, has already been installed. So then we just need to go in and do the internal fit out. So putting up walls, putting up doors, putting in furniture, installing floor finishes, ceilings, that sort of stuff. And what this software enables us to do is go into a building that we haven't built. We don't know how it's been captured. We might not necessarily have the information from the previous contractor who built it, but it enables us, I'll just replay that video again. It enables us to go in and capture a live representation of what that building is. And what we're able to do with that is we're able to base our design upon the point cloud that we've produced, because we know the point cloud is accurate because we've gone out and we've picked it up and we've scanned it. And what it enables us to do is be a lot more accurate and have a lot more assurance around what we're designing is actually going to work, because we know that's what's been captured on site. Now, the actual technology itself, the process that you follow, and what's shown on the screen actually on the right hand side is actually our canteen in the Oldgate office that we went in and did a scan of. The actual process, what you do is we take this tripod with a laser scanner attached on top, and you set it up and you click go, and then all it does for 5, 10, 15 minutes, however long, it will spin on the spot 360 degrees for 10, 15 minutes, and it will shoot out lasers. And what it will do is it will calculate the time it takes between when it sends out the laser and when it bounces back from when it's reflected off a surface. And that's how we build up this mass of points. So this scanner is spinning around 360 degrees and it's shooting out all these lasers. And what we're starting to do is build up this this mass of points, this build up of point cloud data. And eventually we do enough scans and we get to a situation like we do on the, sorry, I realise that's the wrong, I'm trying to show this one here, where we can build up and actually capture full scale scan of the building. Now on the right there is actually, it's the second half of the O2. So ISG did the fit out for the retail side of the O2 building, which obviously some of you might have been and seen. And as we're flying through, if you have been there and you have seen it, you'd recognise that we've got these massive structural supports holding the canopy up. Now what we actually did is we went out and we scanned it, and then we're able to implement that into the model, and we're able to design around where these structural supports come in, and we have a lot more certainty. So we're doing this exercise during design so that we don't have to do it during construction. So construction can go a lot more smoother, it can be a lot more streamlined, and we're picking up a lot of these issues during the design phase. Now it's a very intelligent piece of software, very intelligent process for how we can utilize this information, to the point where, you know, a laser scanner in itself can cost you anywhere between 30 to 80,000 pounds. It's not a cheap piece of equipment, but we do actually have that in-house at ISG, and a lot more companies are actually starting to realize the benefit of utilizing this kind of technology, because it saves some time, it saves some cost due to potential changes further down the line, and it's easier to interpret. So not only being just the software to, you know, visualize what's already there on site, it's there to develop the design, make it better, you know, do multiple iterations of the design and ensure that what we're actually designing is aligned fully to what's on site. So again, we're getting to that construction phase, and we are, resolving issues before getting to site. Now, this again is a bit of a gateway. There's loads of other potential use cases for this type of information. The point cloud itself, we're showing it in its quite basic form, being able to just overlay it in a model, but there's a lot more intelligent stuff that goes on behind it as well. So there's a massive industry for this sort of stuff, and it's almost created a new role in itself. We traditionally have surveyors that go out to site to set up certain bits and pieces, but it's almost in the last few years a new role has emerged, a laser scan engineer or a laser scanning surveyor or something like that, whereby your primary job is to just go out and laser scan buildings. There's a lot of processes and the way you scan that needs to be considered. Like, it doesn't deal very well with glass or reflective surfaces. So you have to take that into account. You have to move around the building, and how best can you stitch all the laser scans together like a big jigsaw. So it has developed into a new role itself, which is quite an interesting concept, and it's being utilised constantly throughout the business now. But it's something that's only come into kind of fruition in the last 5 years, probably, pushing back. I think the software or the technology has been around for a while, but actually utilising and implementing it within construction is certainly picked up in the last few years, because we're also talking about millimeter accuracy here as well. When we say we go out and capture these conditions on site, this building, we're capturing it as accurately as 1 or 2 millimeters, which is tiny, absolutely tiny. So it's very accurate information, and people are starting to jump on that actually, for the sake of getting somebody to go out and scan it, we're actually saving money down the line, because we're spending a little bit of money at the beginning of the project to get this information produced and it all stitched together and overlaid in the model. But then we're not spending money 6 months down the line, a year down the line, 2 years down the line, whenever it is, when we come to construct the thing, because we've already done that exercise of validating what's on site. So anything to add?
Yeah, a little things. I wanted to just say that from the software point of view, that we are showing this recap. So recap is the software that we use to see the point cloud, to look at it. But the technical software that the guys are using for the laser scanning, I mean, to open the point cloud, to put in the right location, and to set up what is the coordinates, etc., are other software. Sometimes they are specific for the machine that they are using, and sometimes they have other software for using and setting up out the point clouds. And again, we have a lot to learn in there, and it's as you said, a proper job, a proper career in laser scanning.
Cool. And on to another interesting bit. Donatella, do you want to run through this?
I would say this is the coolest part. I'm happy to have it. So virtual reality, I am sure that most of people in the call know what it is. So I don't know if you ever seen these people wearing the goggle and looking at this black stuff and actually being in another dimension. So many times, so I think that here there was the need for the client or for the users to understand how it would have been to be in this space, whichever it is, because it can be a school, it can be a hospital, it can be a leisure center, as you can see. And so client users, I mean future customer anyway, were asking, can I walk inside? Can I touch, I don't know, can I touch the kettle? Can I move in the kitchen to understand how it is working? Can I be on the balcony to see the panorama for real? And this is the answer, really. There is like, yes, you can. So we are taking the 3D that we created for the project to put together the project. And actually we make this walkthrough. It's not just a walkthrough. We are making nice a texture, we make sure that the colors are right, and this is really to give to the client the feeling to be inside the space, inside the built environment that we are going to deliver. And it is a fantastic tool for them to understand if they like it, and at the end of the day we want them to be happy, to like the space that we are creating. And this is as I don't know, fit out is a specific case where actually we want to make the client happy to be there, to live there, to use the spaces. Obviously, with school is the same. We want the kids to be happy about having the yellow on the wall, or to have and not having a black or a dark gray. There are situations where we want them to use the space, to be happy. So in technical terms, we are using different software again. Usually they are gaming engine where we put the 3D. It's not us specifically, because we are more about the management of the process. So we are not creating the virtual reality, but other part of our team are. So they take the 3D models that we are creating, or the designers are creating for us, and they are putting these in this gaming engine. And do we know any engine that they are using?
Yeah, so the examples they're showing on screen at the moment are actually derived from the Unreal Engine, which is it's you know, it's already pretty much all pre-programmed in. It's just a simple case of dropping the models in, putting on a few materials and textures, and then creating some interactions.
Yeah.
And I think it jumps back to something we talked about very earlier in terms of these new and these new and emerging roles are actually finding a place within construction. You know,
True.
we at ISG actually have games developers employed through ISG for this exact reason. You know, the world between construction and game development is obviously massive, but construction's starting to see these similarities and these links between. Sorry, I realised that stopped. Between these two worlds, and we're starting to utilise this. It's not new technology by any means, but they're starting to implement the technologies that are out there and available for new processes within construction. So you know, thinking away from the traditional the traditional roles of a planner, a construction manager, a project manager, and some of the more boring roles, they're looking towards more of you know, implementing like games developers and programmers and planners, and you know, there's all these new bits and pieces.
I think now what we are trying to do is to do the same thing that we were doing before, but with a different approach or with a different tool. So this is creating efficiency, but also what I wanted to say is that there is the reason why we are looking for these new minds, also people coming from other industry, developers, but also I cannot think about it, but a lot of data are involved in these processes. So we are working with people, they are working with data, they are creating database. We are really looking for another way to discover again the construction and make it better. So it's not just having the traditional design manager, the traditional architect, the traditional, I don't know, MEP engineer. We are looking at the same things but trying to make it work, and sometimes we need different expertise or different background or different experience to get there. It's not just us talking about construction all the time.
Definitely. I'm just going to carry on because I'm a bit conscious of time.
Yeah.
And all I really wanted to do for this kind of last 5 minutes is talk around some of the future gazing stuff. So a lot of what we just looked at over the past few slides is kind of the norm. When we talk about BIM and technology within construction, that's the norm. That's where we're currently at. So we've got 3D design, we've got 3D validation, we've got interlinking program with 3D models and, you know, point cloud data and the VR virtual reality and the rendering side. But just looking ahead to kind of towards where the industry will be in perhaps 5, maybe 10 years, and what obviously if there's any individuals looking to go into the construction space in the near future, what you can sort of expect to come out of that. And really, the future is all based upon data. I know it doesn't say that at the top, but it's based around data and how we can utilize data to better deliver projects. And as an output from that, you know, we can look at things like robotics, automation. There's you know, all these other potential aspects. And all I wanted to do was quickly fire through a couple of slides just to kind of show where the industry is at the moment, what they're trialing, and what they're potentially looking at rolling out. So this was a case study quite a while back now, but essentially looking at exoskeletons. So utilizing these built-in kind of pneumatic suits to assist with heavy lifting. Yeah, so instantly through that, it's less stress on the actual workforce itself, and looking at implementing technologies to better assist in the day-to-day how people deliver projects. So a typical example being an exosuit, an exoskeleton vest, whatever it might be. There's things like hard hats where they track things like water levels and CO2 outputs and all this other stuff that's all predefined to make, you know, health and safety to the individual a lot more a lot better. Another big massive piece is the Internet of Things and how we can utilize the data derived from smart devices to feed not only the operation of buildings, but how we can better deliver projects. That's obviously another massive piece that we'll get there in the next 5 years, 10 years, whatever it might be. Drones, another massive one. So similar to the point cloud scans, which is very much a freestanding unit, a freestanding tripod that spins and scans. There's the implementation of drones, so flying over predefined flight paths to capture images, do videos, do similar point cloud data. That's another massive one. Similarly, concrete robots. So when I say concrete robots, I'm talking about essentially 3D printing concrete structures. So having these devices set up to take the manual approach to pouring concrete, you know, the traditional old, we bring it over by a crane, pour it in and let it set. There's actually robots out there that they're looking at trialing and developing to make this process automated. Similarly, the same with bricklaying. You know, these traditional ideas of construction is, you know, bricklayers, you know, mixing concrete and all this other kind of old traditional approaches to construction. But actually, where we're pushing as an industry is to automate all this. So 10 years down the line, 20 years down the line, whenever it might be, we're not going to have bricklayers. We're going to have a robots engineer that actually manages the bricklaying robot. And it's those new roles that potentially open up within the industry through this development of technology. Another example is 3D printing. So we've got capabilities in-house to do 3D printing, albeit not to the extent of the example that's shown on the screen, but 3D printing elements. So rather than going out on site and installing it on the fly piece by piece, we can actually 3D print it off-site, have it delivered to site already installed, and just drop it in. This is a typical example of a 3D concrete bridge that was printed, sorry, not concrete, sorry, steel bridge that was printed in, where was it, Amsterdam? And it was like the first 3D printed like major structure that they had they 3D printed, and I can't remember if there was. And again, you know, this notion of 3D printed homes. I know there was some talk on some of the Western countries were doing it somewhere out west. Of this notion of 3D printing homes. Can we do it? Is it feasible with the advancement of technology? Several years down the line, yes, it might be, but it's all these new and existing, it's all these new ideas that are coming into construction that will streamline how we traditionally deliver a project. And it's those kind of technologies that I think, you know, we want people to take away from. You know, it's turning less from perhaps a people focused construction to a more robotics and automated off-site fabrication process. It's all becoming a lot more intelligent. Which is opening up a lot more opportunities, a lot more new roles coming into the industry, to the point where I think Skanska, who are one of our main competitors as a main contractor, have actually employed robotics engineers themselves already. I haven't got it as an example on here, but they've got robotics facilities in-house, not robotics facilities, but obviously robotic different pieces of equipment in-house that they utilize on their sites. And what was it? It was the Boston Dynamics, the old Spot the Dog, or whatever it was. I can't remember the correct name of it. It's all that kind of technology that we can expect to come through into the industry in the next however many years. So it's something well worth having a look at and investing. But obviously keeping your mind open that there's this potential, this capability to implement those skills within construction. And I suppose as the kind of last, sorry, I appreciate we waffled a little bit, but for the last kind of 10 minutes, are there any questions?
We do have a lot of questions. Yes.
Oh, really?
That's
I've not been able to see them, so.
Oh, yeah, Ben and Donatella,
Karen,
thank you
Ben
so
and Donatella. Yeah, thank you,
That's
Karen.
all
Karen, did you catch the questions? Do you want to go through those with the guys? Because there's loads up there. So if you forget any, I'll butt in. But can I just say publicly while I'm here, you three, that's brilliant, absolutely brilliant. I've got the plumbers texting me. I've got the chippies asking me about robots because some of them haven't got Facebook accounts. So yeah, really got loads of questions up there. Anyway, enough of my chatting. Over to you guys.
Yeah, fantastic. Thank you so much for your interaction as we've been speaking there, and hopefully you can really see about how we've been able to showcase IT and technology within the built environment to obviously aid the efficiency in the process there, and that any one of you can really, looking at your existing college subjects, can look at a pathway into construction, and it's open to all regardless of your gender, your background or your ethnicity, as you can see from our varied team with a variety of exciting roles on offer. So I have got a number of questions.
Yep.
So I'll raise the question, and then if you want to just indicate who's the best to answer this. So Ben, I know when you were giving the overview of the O2, do you feel that digital tools and technology can be used to reduce the physical building costs? And then how do we actually pass these efficiencies on to the customers and to reduce the price, therefore, of the building? That was one of the questions that came up.
Definitely, yeah. So the whole approach around BIM, going back to the initial kind of standpoint, is that we're trying to cut the inefficiencies out of the whole process. So we're not talking about just on-site construction, we're talking about all the back-end stuff as well that goes into developing a project. Specifically looking at some of the on-the-site, or the actual on-the-ground construction practices. What we're able to utilize is, so what you'll have on a project traditionally is an estimator, or somebody responsible for sitting there and pulling figures together that basically says, Mr. Client, we're going to charge you X amount for this project based upon these rates. What we're able to actually do with the model itself is to give assurance and actually run checks from the model to automate the extraction of certain material quantities, the piece count of certain material, and essentially to cut the original asking price down, because we've got a lot more assurance around what we're offering the client. Typically, an example of that was something we did on Lord's Cricket Ground. Massive structural frame going up that originally the price was submitted as X amount based upon however many pieces of steelwork. Well, actually, as the design was developed, we were able to do a very easy extraction of all the steelwork out the model and go, hang on, Mr. Planner, hang on, Mr. whoever it is on the project, you realize you're pricing for X amount when really we've only got 50% of that or 75% of that. And it's utilizing that information out of the model to create those automated processes to deliver that.
Brilliant. Okay, I've got a number of other questions.
Sorry, let me just ask. Let me just add a super little point. So we have also some case studies where we were saving money for real. Like we have saving, I don't know, 30% of the cost of the structures because we were really double checking the money on a little school. We have been rechecking the ceiling in your project. Which one was it, Ben? The ceiling case study that we have in place?
Ceiling case study.
Yeah, I
What's
think it is that way. We were rechecking all the ceiling that we were installing on site, and we figured it out that actually we were saving £60,000.
Oh, that was yeah, that was a primary school that we were developing in London.
So we have been seriously a lot of money just to really double checking the quantities. These can be applied to clashes. Though in the case of clashes, we can say, I don't know, 20%, 10%. It really depends on the project. So we cannot say a specific percentage, but I would say that easily 10% is saved because of BIM on the project. Sorry, good.
That's okay. So I think that picks up the cost ones. There was a number of questions about BIM and technology and how much that save on the efficiency, on the cost and labour. So I think that picks up there. Andy raised a question. He uses Trimble and Unity when gaming. The technology seems very similar. Are there links to gaming? I guess in a quick sort of answer there, because we've got a number of other questions.
I mean, yeah, very much. Obviously, there's Unreal was the one that we showed, but there is the Unity development as well that we're looking at in-house at the moment to create custom platforms. Models are developed in such a way that they can be quite interoperable between different software. Obviously, the software has to be set up to enable that exchange in the first place. But there's no reason why we can't just pass information over. But Unity is definitely one we're having a look at. And again, Trimble, obviously predominantly being a surveying laser scanning application. Obviously, we use Faro. There's also Leica. There's all these other different applications. Obviously, we didn't mention it. But yeah, Trimble, again, very similar interaction with the models and bringing through point cloud data.
Fantastic. Kim raised a great question. How do you use BIM on a muddy building site, or do you come back to the office? Do you want to give an answer on that, Ben?
Yeah, that's fine. So a critical part, like we mentioned, is the visualization of the models. So we're visualizing the design, but obviously we're also utilizing the models down on site. So there's many pieces of software out there. And again, I suppose the kind of key takeaway is that if we got a 3D model, there's a software for it somewhere that will do what we need it to. There's exactly. There's applications to be able to push that model down onto tablets, phones, whatever it might be, to live link and even integrate with perhaps some of the site activities. So raising daily site diaries or raising RFIs or all this other stuff that construction managers generally deliver on a project.
Okay, and there's two questions that appertain to roles and different roles that are linked to virtual reality packages.
Yep.
So one of them asks about the apprenticeship and graduate programme route. Jay, I'll pick up on that question. If you listen this week to my colleague Emma Simpson, she'll be able to talk to you on Wednesday about the different routes and pathways in to the construction industry. So it's definitely worth tuning into her. So Jay, hopefully your question will be picked up there, but we can answer your question bespoke afterwards. Louis as well, the different roles that are linked to virtual reality packages. Do you get qualified first in VR or on the game side for first, Ben? That's Louis.
Not necessarily my expertise. I would say it's a bit varied. I know we have employed games developers direct, but then I know we've also got visualizers who probably have no experience within games development. Who then pick up the VR stuff, and it's very much all intertwined. I think it'd probably be done on a use basis or how much that role is needed, if that makes sense.
Yeah,
as long as you've got the skills.
Okay. So in terms of the hazards that we might detect using the technology, Danny asked, can BIM scanning be used to detect some of those hazards? And was there an example of any one of them that we have seen, maybe a hole, a mine, a World War II bomb or anything like that? Have you ever known anything in the office that you've been able to pick up through your investigative skills?
I didn't do in this office with this company yet, but before I think that this is much more used for infrastructure because you are working with the ground and underground much more than we do with building. I think it is applicable to both, but for infrastructure is something very essential. So yes, you have some specific 3D scan, so some machine where actually you can set up the density of the laser, so how the deep you want the laser to go. So we were scanning the ground to see where the surface is. We were also scanning the walls. So, you know, the concrete has a different density of the steel inside. So actually we could see these two different things, or three different materials, and then on the base of where things were, we could do different penetration. And this is the same for ground. When you know where the surfaces, imagine about the gas, the surfaces are, you need obviously to avoid the gas pipes, and that's why we were doing this. So just to know where doing the penetration. In this way, we were reducing to zero the risk. If you're doing penetration, you don't know what is there, I would say that the risk is very, very high. So we definitely can do this laser scanner for reducing risk.
Brilliant. Okay, so I think that picks up a number of questions from Max, from Danny and Mabel, asking about unusual things that we found on our site. I'm just very conscious of time.
Yeah.
We've got 3 other questions about the reality and the future from Gavin, and we've got around will there be a site project that is totally reliant on robots going forward from Jen. So I wonder whether we should just end there on the future of your last kind of thoughts, really, both Ben and Donatella, about the kind of futuristic side. And then we'll hand back to Debbie to see if there's any more time for questions. So both, maybe Donatella, what's your thoughts for the future?
Very, very short one. I would say that we will have a lot of robotics, I would say, in 10, 15 years. But obviously this will be always managed by the person. Like we will have a developer, robotics engineers in place. They will manage it for sure. So the people are not going to be away from site. They will be there. But I think that just the roles will be transforming and evolving a lot.
Ben.
Yeah, definitely. I think, you know, as the industry develops, new roles will open up. Certainly the key focus, as with any industry at the moment, is on data, how we can implement and utilize data. With that will come enhanced processes for how we can integrate robotics and all the other kind of future gazing good stuff that we talked about earlier. Yeah.
Brilliant. Thank you so much. I just want to hand back to Debbie. There's a couple of other questions around the routes and the pathways, but again, hopefully, Debbie, you'll direct those through on Wednesday onto the session there with Emma.
Absolutely.
Thank you.
I was going to say, if there's anything technical or any questions we didn't get a chance to answer, then fire them through, and we can do a response to
later.
those.
Yeah,
exactly.
That's brilliant. And on behalf of West Suffolk College, Donatella, Ben and Karen, can I just say a huge thank you. I've had loads of questions come through. There was obviously the plumbing group listening, CBE level 3 were listening, the Berry Town Trust group were listening. So I can see that from my machine straight away. So thank you for talking personally and passionately about what you do. And, you know, I think you've touched the hearts of some of our guys and girls here. So thank you very much. And I'll email the extra questions through.
Perfect.
Cheers. I'll speak to you soon.
Thanks.
Thank you.
Thank you very much.
Bye, everyone.
Thank you.
Cheers.
Bye.
Bye now.
Bye.